Section 9.3, our objective today is I can define and apply properties of arcs and central angles. So first we're going to define what a central angle is. And a central angle is an angle whose vertex is the center of the circle. Or in other words, an angle formed by two radii. So I have this radius and this radius. So angle AQX would be a central angle. Okay? So would angle AQB. So would angle BQY. Those would all be central angles because they have their vertex on the center, at the center of the circle. Okay? And then we have what's called an arc. An arc is an unbroken part of the circle. Okay? So notice that radii QA and QX intersect the circle, and they break the circle up into parts. And so this is what we would call an arc. And the symbol that we use, we would read that as arc AX. Okay? We also have arc XB, or we have arc BY. Okay? So all of those are arcs of the circle. Now we have different kinds of arcs. We have what are called a minor arc, and that's an arc whose measure is less than 180 degrees. Remember that a circle is 360 degrees, and so a minor arc is an arc that's less than 180 degrees. Okay? And then and minor arcs are always named by 2 points that are the endpoints of the radii that form them. So A and X are the endpoints of the radii that form arc AX. Okay? And so if it's a minor arc, we always name it with the 2 endpoints. Then we have what's called a major arc. Okay? A major arc has measure greater than 180 degrees. And for major arc, we always name them using 3 points on the circle. So if I was going to talk about major arc X, BYA, okay? And we always name it in the direction we're going around the circle. And for the most part, it's we name them counterclockwise. So we would say arc BYA is that that teal color arc. Okay? So if a minor arc is measure 180 degrees and a major arc is measure of greater than 180. So what is exactly 180? So exactly 180 would be a semicircle. Okay? And so we would say arc XBY is a semicircle because X and Y are endpoints of the diameter, okay, which means it divides the circle in half. We also have arc YAX, so that means I'm starting at Y, going through A, and stopping at X, which gives me a semicircle. Now the thing that's important is that the measure of a central angle is equal to the measure of its intercepted arc. So this angle is 90 degrees. Angle AQB is 90 degrees. So that means arc AB is also 90 degrees. Okay? And so that means arc ABY, it's half a circle. So the central angle is 180. So that means the arc is 180. So that's the key idea, is the measure of the central angle equals the measure of the intercepted arc, and vice versa. So if this one is 90 degrees, arc YA is 90 degrees, that means that this angle must be 90 degrees. Okay? So, looking at an example, if I have this circle and I center at E, and I have EA, EB, EC, and ED, and this is angle 1, angle 2, and this is 80 degrees, and this arc is 70 degrees. Then measure of arc BC. Well, BC is this one, and it is formed by the radii that give that angle, so that means that this arc also has to measure 80 degrees. Okay? Measure of angle 1. Well, if this is 70, then that means this angle must be 70 degrees. Okay? Measure of arc AC. Okay? So measure of arc AC would be this arc plus this arc. So that would be 150 degrees. And so we got that by adding the two arcs together. And that's because, just like we have the segment addition postulate and the angle addition postulate, we also have the arc addition postulate. Which says the measure of the arc formed by two adjacent arcs is the sum of the two arcs. Okay, so we can add adjacent arcs together to form a larger arc. Okay, and so in this picture, if I want measure of arc ADB, so that means that I'm going to start at A. I'm going to start at A, go through D, and until I get to B. So we're talking about this whole arc right here. Okay? And so the whole circle is 360 degrees. But I'm leaving out this much, so I subtract that. So I get 290. So the measure of arc ADB is 290 degrees. Okay? And then we have one more theorem. Okay? And the theorem says in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. Okay, So an example is if I have this picture, this is my center, this is J, K, L, and M, and this is angle 1, and this is angle 2, okay? So it says if measure of angle 1 equals measure of angle 2, or actually let's do it this way. If angle 1 is congruent to angle 2, then arc JK has to be congruent to arc M or LM. And vice versa. The converse is also true. If arc JK is congruent to arc LM, then angle 1 has to be congruent to angle 2.